Hello and welcome. In this video, we will review the various performance data that are produced by performance testing of storage devices on OakGate Technology's storage verification framework. This video is the second part of a series on performance testing with the OakGate product. In part 1, we set up and ran an automation performance test script on two devices, an 80 gigabyte Intel brand solid-state drive, or SSD, and a 300 gigabyte 7200 RPM Maxtor brand hard disk drive, or HDD. Each device was directly connected to the OakGate appliance via a SATA 2 300 gigabit per second interface. The test script was designed to test small block I/O, block sizes of 512 bytes through 32K bytes. In the second part, we will examine the captured data and graphs that are used to analyze the I/O characteristics and performance of the drives. We're looking at the graphical user interface of OakGate's controller. In particular, we're looking at the automation test panels at the completion of the performance test, which ran for over 18 hours. The performance test script, shown in the center panel, is organized into test sets, with each test set containing one or more related tests. The test sets are labeled in black, and the individual tests are labeled in green. The green color indicates that the test passed successfully. We can see that in this case all of the tests have passed successfully. Test sets 1 and 2 are device preconditioning. Preconditioning is needed to get the SSD to a steady state so that the subsequent performance tests show valid data, numbers that can be expected under normal operation. The performance data gathered during the preconditioning shows some interesting characteristics of the SSD device prior to achieving steady state operation. Test sets 3 through 6 are the actual performance tests where the devices are operating under normal conditions. These test sets measure the performance of random reads and writes and sequential reads and writes. Within each test set, two variables are modified, the I/O block size and the command queue depth. For each I/O block size, the command queue depth is iterated through 6 values, shown here. The performance data produced by the OakGate product is in 3 forms: interactive graphs within the OakGate controller's GUI, HTML pages viewable with a standard web browser, and CSV files viewable with Microsoft Excel or a similar spreadsheet program. The CSV files contain all of the actual data point measurements taken during the testing. The graphs are based on these same data points. The interactive graphs are viewed from within the OakGate controller. For example, select the Performance Graphs subtab, click on the Random Reads test set label, right-click on the label, select Show Graph, pick a device path. We'll pick the SSD device, and click the Graph button. These graphs show data points with coordinates of I/O block size on the x-axis and the measured performance on the y-axis. The measured performance is either I/O operations per second, bandwidth in megabytes per second, or latency in milliseconds. When multiple command queue depths are included in the testing, as in these tests, the data points for each queue depth are shown as a series, each in its unique color. The lines connecting the data points within the series are helpful for visualizing trends, but note that only the data points represent measured values. The lines between the data points do not represent performance measurements. Let's make the graph panel larger to take a closer look. These graphs allow several interactions. First, the x-axis can be scaled in either linear or logarithmic values. We switch the scaling via the 2 radio buttons under the graph. We currently see linear scaling. And this is the graph with logarithmic scaling of the x-axis. And back to linear. Second, individual queue depth series can be removed from the display via the checkboxes under the graph. This is helpful when one series overlaps another in the graph. Let's remove QDepth1 red to better see QDepth2 blue. And now let's remove QDepth2 blue to better see QDepth4 green. And now we'll turn the two back on. A third interaction is the ability to zoom in on any section of the graph. For example, we'll zoom in on the data points of the first three block sizes. Zoom in is accomplished by clicking on the upper left corner of an area to be enlarged and dragging to the bottom right corner. Then release. And you can zoom in further as needed. To return to normal view, click anywhere on the graph and drag up or left. And the next interaction is that if you hover on a data point, the specific coordinates are shown. For example, here we see block size 16 by 0.55 millisecond latency. And then we see block size 32 by 1.632 millisecond latency. This feature works as well when the graph is zoomed in. And the final interaction allows you to call up a second level graph which shows the detail behind individual data points from this top level graph. The data points shown on this top level graph are actually average values of more detailed data measurements. Clicking on a data point brings up the second level graph, which shows further detail. Second level graphs, which appear in a pop-up window, support some of the same interactive capabilities as the top level graphs. We can resize the window. We can view in linear mode, shown now, and also in logarithmic scaling. We can zoom in on a section of the graph. And we can see specific coordinates by hovering on a point. The second level graph for latency is a histogram showing the number of I/Os for each latency time in microseconds. The logarithmic scaling is especially useful with this graph, as less frequently occurring latency times may not be visible with linear scaling. The second level graph for IOPS and bandwidth are a bit different. These second level graphs show performance over time in seconds. And again, we can zoom in and hover on a data point to get an exact coordinate. An additional feature of all the graphs we've seen is the CSV button in the lower right of each graph. When we click on the CSV button, we are presented with a Save dialog window, allowing us to save the detailed data to a file. Select a folder. We'll put it in a folder on our desktop that we've created for the CSV files. Give the file a name, and click the Save button. Next, we can open this file and see the actual data. And here's the data in an Excel spreadsheet. Now we'll adjust the spreadsheet a bit. And close the Explorer window. Then adjust our second level graph window. And now we have the data and graphs side by side to analyze the performance information. Notice the matching data between the CSV file and the graph coordinate. Okay, so now let's take a look at the HTML view of the data. The HTML pages provide access to the performance graphs and data with a standard web browser. This allows the information to be viewed on a PC that does not have the OakGate controller installed. We're looking at the top-level HTML page. From here we can get to all the graphs and data. The body of the page is a table. The first column of the table lists the test sets. Each name is a link which provides access to the graphs for that test set. The second column lists the individual tests of the test sets. Each of these names is a link which provides access to the details about the setup and results of that particular test. We'll look at the page of an individual test first. Let's pick 4K writes. The page starts with test setup information. This is the configuration settings from within the automation script. Setup information is followed by test results. Here we see the results for iteration 0 of the test. The average values of each of the relevant performance measurements is shown. This information is repeated for each iteration. Now let's go back and look at the HTML pages of a test set. We'll select the random writes test set. Here we see graphs that are equivalent to the graphs available in the OakGate controller. However, the graphs within the HTML pages are not interactive. The first graph shows the performance measurements for IOs per second. Each graph is shown with both linear and logarithmic scaling. This is IOPS with linear scaling. Notice the checkboxes below the graph. And here's the IOPS graph with logarithmic scaling. Following the IOPS per second graphs are the bandwidth graphs, and then the latency graphs. The graphs are followed by a table. Since the graphs are not interactive, this table provides a way to access the second level graphs and the CSV file data. The table lists the data points from the prior graphs in columns 1 and 2. Columns 3, 4, and 5 provide the links to the additional information. As an example, let's pick data point QDepth2 IO block size 16. In the bandwidth column, click the yellow CSV icon. And we see here the file is saved. We can now open the CSV file. And here it is in our spreadsheet. We'll do a quick column adjustment. And leaving the CSV file open, we'll go back to the HTML page and click on the corresponding multicolored icon bar to get the second level graph. We scroll a bit and adjust the window size. And now we've set up the second level graph besides the data point that the graph is derived from, just as we did earlier within OakGate Controller's GUI. Notice the CSV button on the graph page. This is an alternate way to get to the same corresponding CSV file. We've now returned to the prior HTML page. If we scroll back to the top of the page, there's one more item to notice. Here we see another CSV button. This CSV button accesses the file that contains all the data used to generate all of the top-level graphs that are shown on this HTML page. As you have seen, OakGate Technologies' storage verification framework creates a complete set of performance measurement reports in several convenient formats. This provides our clients with a complete set of documentation to both analyze their storage products and present the results. Thank you for watching this video. For further information, please contact OakGate Technology. We look forward to hearing from you.